Right, one of our experiments today, well not today, tomorrow, is going to be using a signal generator. It's dead simple, okay, there's the little signal that we're going to take out of the signal generator. You can have a square wave or sinusoidal wave. You've got amplitude here, loudness if you've got it attached to a loudspeaker, and you've got your broad frequency ranges times 1, times 10, times 100, times a kilohertz. And then this little one here, okay, that goes round, and that's a sort of multiplier. So you can get loads of different frequencies that comes out of here. We're going to be using this, okay. That's going to be what goes into here. Now this is our oscilloscope. So let's have a little run through before we eventually put that into there. Okay, well actually we could put it in there as well, doesn't really matter, but we're going to put it in there because that's channel 1, and 1's better than 2 there. So okay, let's go to work. Okay, first of all, there we go, there's a marrow. You won't get a marrow when you have this experiment. Okay, there's the power button. So okay, dead simple. It took me ages to find this power button, so just in case you're not as rubbish as me, here you go. Okay, off, on, there we go. Now when it first turns on, oops, let's have it all this way. It says press any key to enter, and you can just, it really doesn't matter, anything, just press one of these and then we go. Now so far there's nothing on there. Okay, so let's take our coaxial cable and pop it into one. Oh yeah, and we've got quite a, what's the frequency we've got here? I've got 100, maybe 2000 hertz, something like that. Okay, right. I've noticed just by messing around with it, because it comes with an Enormo data manual, which I just haven't had time to read. I found that this is cool. So if you're really stuck and nothing works, do auto set. If you press auto set, this happens to the display. It kind of cycles around loads and loads of things and decides what the best thing to display the voltage is, and the best time scale, and the best time base. And if we just look at this display here, okay, forget that right hand side, forget the trig mode, that can go away. What you've got here is not a proper cathode ray oscilloscope. It is an oscilloscope, which is measuring things that oscillate. So let me turn that round. Okay, and what we got then is down here in the bottom left. That's the display, which tells you the sensitivity of the vertical squares, if you like. Okay, so at the moment on channel 1 we've got 5 volts per centimetre. That basically means that square there is 5 volts. In other words, each one of the little things, okay, is a volt. So you can see there, that's probably about 5, getting on for about 5 volts ish. There's a great little thing I've noticed on this. There's a little red marker there, which if you move your waveform up and down by using the vertical position, so here's channel 1, okay, it's in red, that's why the trace over there is in red. Okay, if I grab hold of this and move it up and down, can you see over here you've got this wonderful little marker which tells you where you've moved it up to. And also what's really great is as you move it back down again, okay, you can see it coming back down, you can see the scale on the bottom here. Okay, so let's just get that up again. Okay, it tells you when you've got your waveform centered, because that channel 1 will be 0 volts. Brilliant. So this is something we're going to be using later on. It makes it really easy for kids to measure voltages. And there's a similar one for the time base. If I want to move over here, this position one basically moves this that way and that way. So if I just do that now, you can see me. There it moves. There it moves backwards. But look at that at the top. It's ace. It actually tells you when it's zeroed in. Just a little bit more fantastic. So now that waveform is perfectly set. down here and up there, and it makes it really easy to be able to move this around and measure the amount of time it takes for a complete cycle, something that they have to be able to do when they need to measure the frequency. So there we go. Now let's change some stuff over here. Okay, so I'll change the frequency, I'll move it down a bit, and as you can see, okay, now, okay, moving it, frequency up, frequency down, really simple. Now I'm going to try and set it to something on here which looks about right, so maybe about 10, and that's on 100, so maybe about 1,000 Hertz. Let's see if we can measure the frequency by simply taking how long a time this shape takes. Now remember that this up here is on 0. So what I'm going to do is I'm going to take, where is it, this, and move it until, I'll move it this way, until the waveform begins to repeat itself. And I'll move it this way, it's not there yet, a bit more. Let's really make sure that works nicely. Is that in the middle? Yeah, that's in the middle. So that says that that is 1.21 milliseconds. Right, well, back over on the calculator over here, okay, this is going to be a nightmare, okay, 1.21 milliseconds, okay, 0.00121, that's milliseconds. Okay, now the inverse of that should be the frequency, okay, 826 Hertz, that's close enough for jazz for me. So that's using the little markers here, okay, to be able to start from the 0 line and move it along until we can find the amount of space on this horizontal axis, and this is the time axis, that it takes for the cycle to repeat, and that is the time period of that. So the time period of this wave, of this voltage, is 1.21 milliseconds, and that comes out at about 826 Hertz, you know, close enough to 1,000 for me. I'm quite happy with that. If we want to measure the peak voltage, okay, it's dead simple. What we're going to do, remember this started at 0? Well, we're going to take the Y position twiddly pot over here. There it is. It's that one there for the red channel. And I'm going to move it down and until the top gets to absolutely the middle there. So if we look down here, I should be able to see, where is it? Where have you gone? Where have you gone? Da-da-da-da. Oh, I've missed it. Let me go back again. It's all very exciting, this. Playing with the oscilloscopes. Am I on 0? Not quite. I am now. Okay, so we can go up here and let's get this really rubbish iPad camera right in there. Okay, so we can see that the whole of this waveform is one whole square, maybe 1.1, because each one of these little dots here within the square is 0.2. I reckon maybe 1.1 divisions, and down here it tells me that the scale is 5 volts to a division. So I can come over here and I can pop in, let's clear this, okay, 5 volts, and I'm sure we don't really need a calculator to do this, but we'll just do it anyway. Okay, 5 times 1.1 is 5.5. So the shape there has a peak voltage of 5.5. If we were doing the peak to peak voltage, it's going to be 5.5 volts, and 5.5 volts to the bottom as well. So that would just be double that. So I could take that and times that. Oops, 5.5 times 2, and this would give me my peak-to-peak voltage, which is 11 volts. That's 11 volts peak-to-peak. Okay, that's really simple. Measuring the time base and the voltage of an alternating voltage, alternating current. Well, actually, we're not measuring current; we're measuring voltage. But there you go. That's it. Really, really basic. So we'll come back and do some other things with it later on.